Just imagine, you are able to explain a robot all your day-to-day issues. What is stopping you right now?
Sorry, you have hit the context token window limit.
Introducing MemGPT, coming to your rescue. A big step towards achieving AGI, Artificial General Intelligence. Hello, everyone. I'm Pratheesh, and I'm thrilled to welcome you to a brand new YouTube playlist series, AI Chronicles. This series is your gateway to the latest developments in the dynamic world of artificial intelligence. In today's episode, we embark on a fascinating journey into the realm of Mem-GPT, short for Memory GPT. This concept draws inspiration from a groundbreaking research paper, and it promises to reshape the AI landscape. Let's dive right into the captivating world of Mem-GPT. Before I start off, I want to announce that I'll be making more videos on these mentioned topics like using open-source LLMs on local machines, how to use Microsoft's AutoGen with locally hosted LLMs like Mistral 7B, open-source projects on managing agents like XAgents, OpenAgents, DBGPT, etc. So, subscribe to the channel and stay connected. Coming back to MemGPT, let's look at the reason behind the creation of MemGPT. One pervasive issue with many contemporary AI models is their limited context token window. You've likely encountered AI models with names ending like 4K, 16K, 32K, which refer to their context window. This limitation has given rise to challenges like loss in recursive summarization and constrained contextual communication. But imagine what could be achieved if these models had an unlimited context window. We could have enhanced comprehension of intricate documents without any losses. In today's traditional ways, longer documents are summarized in chunks, with each such chunks together summarized again, which would lead to loss of few important contexts. In code generation, imagine you are able to provide the AI model with a comprehensive context of an entire codebase spread across multiple files. Applications in various other domains such as medicine, law, finance, fraud detection, content creation, etc. MemGPT seeks to resolve this issue by affording AI models an infinite context window. Its objective is to create the illusion of extensive memory resources by efficiently transferring data between fast and slow memory. Simply expanding the context window size is not a sustainable long-term solution due to the computational, time and memory requirements associated with the transformer architecture's self-attention mechanism. MemGPT surmounts these hurdles by drawing inspiration from how operating systems manage memory, akin to RAM and SSD HDDs. Before we jump into the architectural insight, let's witness a live demonstration of MemGPT in action. Installation is straightforward as in GitHub page. Once it's installed, you can start the app by running python main.py. Note that by default this will make use of GPT-4, as they claim the function calling is way more efficient than GPT-3 versions. As the app starts, you can see it referring to me as Chad. When I correct my name by telling, my name is Pratheesh, not Chad, it is updating the memory. Same is the case when I am correcting data about me. This information is stored over the successive sessions, like if I restart the app and ask my name, it is retrieved from the memory. MemGPT offers many more options to save the conversation as checkpoints, and we can invoke it on restarting of app. While we start the app, it offers many options like choosing the AI model, picking up a persona, picking up a required archival storage files like .text. We can even pass in a path of a database as context. This screenshot shows on how a database is passed in as context to MemGPT, and we are querying over it like asking the age of a person. This screenshot shows on how to load the last checkpoint conversation as the context and asking about my details. Just imagine, you take a chat dump of a WhatsApp group chat of your close friends and pass it in as context. Now you can create multiple files that could correspond to each person's characteristics and unlock the potential of creating agents with the behavior of your friends. Thus, the possibilities are endless. Let's dive into the architecture now. Presently, if you see the context token window of AI models, the complete message is consisting of 3 parts. 1. System instructions telling the LLM how you want it to behave. 2. Queue of recent event message history between the agent and the user for letting the model know of context. 3. Actual message or the question. Thus, we see that the first two parts are taking off the major share of the space and we are only left with little space for our actual message. As the to and fro of the agent and the user conversation are taking place, the actual messaging window keeps getting smaller and smaller. The design of MemGPT is based on OS-inspired LLM system for its virtual context management. In this design, shaded components is the MemGPT. It includes a fixed context LLM. The LLM is augmented with a hierarchical memory system. It has functions that allow it to manage its own memory. The LLM processor takes a main context, analogous to OS main memory RAM, as input. It outputs text that can be interpreted by a parser. The output can result in either a yield or a function call. MemGPT uses functions to transfer data between main context and external context, analogous to OS disk memory. When the processor generates a function call, it can request control ahead of time to chain together functions. When yielding, the processor is paused until the next external event, example a user message or scheduled interrupt. MemGPT has two main context and the external context. Main context has three main components. 1. System instructions, which hold the base LLM instructions, example, information describing MemGPT functions and control flow to the LLM. 2. Conversational context, which holds a first-in first-out queue of recent event history, example, messages between the agent and user. 3. Working context, which serves as a working memory scratchpad for the agent. External context are responsible for these four reasons. 1. Like disk storage in OSes, external context holds information outside the LLM processor's immediate view, but it can be brought into the main context when needed. 2. Flexible storage, external context can adapt for specific tasks. For conversations, it stores chat logs, and for document analysis, it houses large collections that MemGPT can access through paginated function calls. 3. Querying options, in experiments with chat and document analysis, databases store text and embeddings. The LLM processor can search external context using timestamps, text, or embeddings. 4. Recall and archival, it enables comprehensive event history retention and flexible data management, benefiting both conversation facts and document databases. With that being said, let's look at the performance comparison with GPT-3 and 4. MemGPT outperforms both GPT-4 and GPT-3.5 in retrieving information from a large document set. It maintains accuracy, irrespective of the number of documents retrieved or nesting levels. Some drawbacks include token budget consumption for system instructions. Open source models like Mistral 7b still face challenges with function calls. Considering the fast evolution of the AI models, very soon we can see it gets improved. Another point to mention is, the combination of Microsoft's AutoGen and MemGPT has the potential to provide agents with limitless memory. I'll make a video on how to use open source models like Mistral 7b with AutoGen. So, that's a wrap for today's insights into MemGPT. Stay tuned until next video. Bye, have a fantastic day.